Hello, good morning to all. Today we will be discussing about the topic that is method of the joints. So when we are dealing with the analysis of a truss, we have discussed there are two methods for analyzing the truss. That is one is method of joint and one is method of section. So today we will be learning about the method of joint. So first of all, what is the concept behind the method of joint is that first of all, equilibrium of a joint is considered in method of joint. So we need to maintain a equilibrium at a joint for the method of joints. Okay. So what is the procedure behind it? First step is that find the support reaction considering the equilibrium of entitles. First of all, you have to find out the reactions, that is support reactions, considering the equilibrium of whole truss, entire truss. Okay. Then the second step is consider a equilibrium of a joint where only two unknown forces are available. So it is easy to calculate the or maintain the equilibrium of that joint which is having the two unknown forces. So you need to pick that joints by yourself, okay, are available, and use the equilibrium equation, that is summation fx equal to 0, summation fy equal to 0 to find the unknown forces. Similarly, proceed to the another joint. So first of all, maintain the equilibrium at one joint, then move on to the next joint, then move on to next joint. So similarly, you have to go follow these procedures, or you need to find out the unknown forces using method of joints by maintaining the equilibrium of the joints. So what you need to know some basic fundamentals that are being followed in the method of joints. That is number one note. You can write down that where suppose there's a this member in which the two forces are moving away from each other. So this is the applied load. Okay, and in this case when at the joints the uh, two forces are moving away from each other, so what is the conclusion? If the arrow marks is away from the joint, that it means that the force in the member is tensile. Okay, if suppose this is the joint in which the two forces are moving away from the joint, so that means the member is in tensile member. And second note said if the arrow marks are moving towards the joint, if two forces are moving toward the joint, that means the force in the member is compressive. Okay, so I hope you will remember this point. Write down the another note that if this is the joint, okay, in which one force is coming from this side and one force is coming from this side, so and there is a third member in which there is a force, this FAC. So if the collinear means the same line of action, okay, you know this already, that collinear means which is having the same line of action. So the conclusion behind it that so uh, this note is that at a joint if three members are meeting, if there is any joint in which three members are meeting and two members are collinear means they are having the same line of action. In this case, this uh, FAD and FAB is having a same line of action. So what will happen? The force in the third member is always zero. Then force in this third member will always be zero. There is a condition for that you need to remember. If there is no external load at that joint, there is no external load at this joint, then only the force in the third member will be zero. Otherwise, there will be some force in that member. Okay. So this note is clear that if two members are collinear, the force in the third member will be zero only when if there is no external load at that joint. So now note 4 says that if these two members are non-collinear, AB and AC, these are non-collinear because they are not having same line of action. So force in this member FAB equal to 0 and FAC will be 0 if there is no external force acting at that. When two non-collinear forces. Here you can see that FAB is coming from here and FAC is coming from here. Okay, so the force in FAC and FA will be 0 again because they are non-collinear forces and there is no external force. And here, if two collinear forces because their line of action is same, so the value of these forces will be equal. Okay, this will be you can get easily by applying the equilibrium equation such as summation f x equal to 0 and FAC is, suppose you have taken positive and FAB will be negative because it is having a negative direction. So from here you will get FAC equal to FAB. Now, conclusion says that at a joint, if two non-collinear members are meeting with no external load at that joint, then forces in both the members are zero. I hope this point is clear. If two members are collinear, so the force in the third members will be zero. If they are non-collinear, only two members we are talking. The, so the forces in that member will be zero in both the members. So this is all about the method of joint. Now, if we see the numerical that says, so in this numerical we need to find the force in the member BD. So for finding the force in the member BD, what you will do? This, if you are following the concept of the method of joints, first step is that you need to maintain the equilibrium of whole truss and find out the reactions. So here A reaction, here C reaction. So one vertical reaction at this support VA, one horizontal support HA. Here only one vertical reaction, that is BC. Okay. Now when we have to calculate this reaction. First of all, you will apply the equilibrium equation. So first of all, summation fx equal to 0, and for that the HA value will be 0 because there is no horizontal force involved in this, and summation Fy equal to 0, for that Va plus Vc equal to 10. Okay, and summation moment about A point is equal to 0 if I am applying at this point. So you need to put your hand here and see the reactions from this side. So Vc into this distance, suppose it is not given here. So let us take some distance. Suppose let us take it as 2 here and 2 here. Okay. So and this is also 2. Let this be 2. So Vc into 4. Okay, and 1 will be minus 10 into 2. Okay, this will give you the more Vc value is equal to 20 divided by 4, 5. So that is how we will calculate the values of the reaction. From here we will get a Va equal to 5 km. So now we have the reaction value. So ultimately you need to calculate the value of force in the member BD. So if we will take the joint this D joint, now we need to find the force in the member BD. Either you take this joint, either you take this joint. So you need to calculate the force in the member BD. So let us take FB. It is going from here. So let us FBD. Okay. In this member it will be FDA, or here it will be going FDC, or you can also take here DB. Okay, so this will be the force in that member. So how will you calculate this? Either you have the concept that I have earlier told you that these two members are collinear, therefore the third member, the force in the third member will be 0. That means FBD will be 0 because the two members are collinear and there is no external force at this joint. So force in the third member will automatically be 0. Okay. And if you want to uh, calculate the uh, all the values and put the uh, in this, that what will be the value of FDA, FDC, and then you have to calculate this. First of all, you need to take joint A because now you have the value of VA and HA equal to 0. So you can calculate the value of this one, then you can calculate the value of it. Similarly, you can proceed in this manner in this method of joints numericals. So let us take second numericals, that says, now in this numerical there will be one reaction VA and here one reaction HA, here one reaction PC. Okay. Now in this numerical at D joint there is a load, that is 10 kilonewton load acting. Now you cannot apply that concept here because there is an external load at this point, because if these two members are collinear, we need, you can calculate the force in the third member, but here there is an external force. So for that, if I am picking the D joint, suppose let us take D joint here, one force is acting here, that is 10. Okay, one force is acting here, that is FDA. One force is acting, that is FBC, and one force is acting FBD. So for that summation Fy equal to 0 and FBD minus 10 equal to 0, and from here FBD will be equal to 10. So I, if this is coming out to be positive, that means we have assumed the right direction. So this member that is will be B and this will be D. So one force is acting at 10 and one force is acting, and the forces are going away from the joint. One force, these forces are going away from the joint. When the forces are going away from the joint, that means it is a tensile load. So you can put this as, you can also write down here tensile. So I hope this point is clear, that how will you proceeding in case of the trusses when you are applying the method of joints. Thank you very much.